Alright, so this is for the next part of this assignment, and right here I have a tuning fork, and with this I'm going to be using this for the how sound waves move. So if you're not familiar with the tuning fork, the main thing that you can do with it is you strike it against a solid object. You can notice how it makes a vibrating sound per se, where it makes a specific very distinct noise that you're able to hear due to the metal prongs vibrating back and forth a very high rate, several thousands of times per second, and from that they're able to give off a you're able to interpret that sound. So I'll do it again. I don't know how well that came up on the camera. Alright, so the full-on explanation between that is, so strike the metal tuning fork, the metal prongs, they vibrate at a very specific frequency in which we are then able to pick up with our ears, and we hear that as a little humming sound. As the little prongs vibrate back and forth, they create a zone of high pressure and then low pressure, and we are able to hear those sound waves, and that is the sound that we are able to hear. Now, the main basis of the experiment, and what I wanted to do, is wanted to see how these sound waves, which we hear but we aren't able to see, I wanted to transfer that to something that would be able to do a much better job of explaining this application. So I have this glass of water right here, and we're going to see how quickly I can record this. But the essential goal of this is to see these waves in a more visible way than just hearing them. So here we go. Okay, so we'll try that again as well. So strike it on the side. Okay, so it's very quick that happens, and there's an explanation for that. I'll get to that in just a second. But when we put the tuning fork in the water, you will be able to see in person better, but on the camera picked up as well, that the water ripples a little bit on the surface where the tuning fork has been inserted into it, and that's just the waves that we were able to hear. That's it being transferred over to the water, which we're able to see as ripples. And as you might have also noticed, is that the amount of time that the tuning fork was able to produce that sound for was for a much shorter amount of time. That's because the water resists the motion of the tuning fork at a much greater rate than it does when it's just through the air. So that's why we only notice the effects of the tuning fork for such a short period when we were putting in water versus when it was out in the air. So yeah, that's that.